What's going on, guys? It's Chris here. Welcome back to part 6 of Learning R with Chris. In today's episode, it's kind of an exciting one because we're finally going to be starting to work with some data and not just doing prerequisite stuff. We're actually getting into the meat of it right now. So in today's episode, we're going to be looking at an actual data set that I collected, and that's located on my computer just right in this data directory. It's going to be called qtimes.csv. So what I'm going to do is set my working directory right away to the source folder here. And then we're going to load in the tidyverse as we usually do when we start up these videos. So we can hit this play button on our code chunk. And as you can see, it put that in the console for us and it attached these packages. And in today's video, this is going to be the main focus. So today's video is going to kind of give you an idea of the basics of what you want to do whenever you obtain a new data set. Maybe you want to take a look at the different variables or attributes and maybe plot them to see just generally what you're working with and what the kind of the form of the data is right off the bat. It's probably the best thing to do right off the bat is just plot it and then work from there. So that's what we'll do. So first step, let's load in the data. So we can insert a new our code chunk here and use our read CSV function and then give it the path. So since we're actually our working directory is in this source folder, we're going to want to tell R to move up one level and then go into the data folder and then grab this qtimes. So that's what we'll do. So we say these two dots mean like move up one folder to the parent directory and then move into the data directory and then qtimes.csv. So that'll load in the data for us into a tibble. Maybe we want to assign that to a variable. So qtimes tibble, assign that, and then we can take a look at it as well at the same time. So run this code chunk, and it, as we expected, loaded in the data. And to give you guys kind of an idea of what this is exactly, if you're familiar with the game Overwatch, this is basically instances of searching for a game and how long it took. So the different attributes, this is kind of like a timestamp indicating when you started searching for the game. This rating variable is a scale from 1 to 5,000 and how good you are at the game, like on the competitive skill points kind of idea. This is the variable we're kind of interested in, the queue time, so how long it actually took to find a game. And then this role variable is you can either be like a damage dealer, a support, or a tank, indicated by a D, S, and T respectively. So basically you can kind of imagine how this might be used by like Blizzard themselves, the creators of Overwatch. Maybe they want to, based on these like the timestamp and what rating you're at and the role that you search for, like how long is it going to take you to find a game? That might be like an interesting question for them as developers, right? So yeah, so we loaded in the data successfully, and maybe as a first step, we just want to look at what the data actually looks like whenever we start graphing it, right? So to do that, we're going to use the ggplot package that we loaded in with the tidyverse. So we can insert a new R code block here. And I guess I'll just show you guys, instead of just dumping a bunch of R code here and then kind of explaining it step by step, I think it's actually a bit better for learning purposes just to actually start making plots just from scratch and then show you guys like what they look like at each step. So basically you call this ggplot anytime you want to make a graph with ggplot, and your first argument is going to be your data here. And then, so what does this look like? If we can actually assign this to a variable. So let's say this is eventually going to be a histogram. We'll call it my histogram. What happens if we actually run this at this stage? And we just get a gray box. So we're going to need to tell R a bit more than just plot and then this variable of data, right? So the next thing that we're going to want to tell it is maybe what we want on the axes, right? So that's going to go in this aesthetic function. So AES aesthetic. So you just type that, and then you can tell it what's on the x-axis and what's on the y-axis, and there's some other options as well, but we'll just stick to the basics for now. So maybe, I don't know, which variable do we want to look at? So maybe we just want to see what the queue time looks like, the whole distribution of the queue time, right? For all of our instances of data. So since we already gave it our tibble here, we can just quite simply say, I want queue time on the x-axis. So now let's take a look and see what happened. So as you can see here, we haven't actually told it what kind of plot we want, or like what we actually want to be doing on the y-axis here. So all it did was fill in like an appropriate scale for the x-axis, because it knows we want queue times on it, and make some lines, and maybe add a little label here. So we're still going to need to tell it more. And basically how it works is you're just going to be starting to add elements slowly to your plots as you make them. So this is saying, this is my basic like ggplot kind of like object here, but I also want to add like a histogram geometry, right? So to say that, you're going to say plus, and then you put on a new line, geometry, and then histogram. So there's some options here. You can select how many bins you want. If you don't know what histogram is, I'll go over that in a second. But let's just take a look at our histogram so far. So now it's starting to look like more like an actual plot that you'd want to see, right? So it's telling us that it's using 30 bins, and it's kind of in this gross gray looking color. But yeah, we can start to see like some interesting things about the distribution of our queue times, right? Like we can see that there's a large peak. Well, like most of our observations are around, so this is in seconds, by the way. So most of them is like, they find the game in less than like a couple minutes, right? And then we have some of them, it takes longer over here. So that should be interesting to us, right? Like what's causing this difference in the queue time? Is it because of the time of day? Is it because of the rating? So that's things that we're going to answer later. But for now, we're just trying to get an idea of what the variables actually look like in their distribution. So maybe now we want to look at the role variable here. So I told you that it can take on either like a D, an S, or a T, right? So for that, we'll want to use a bar plot. So we'll say my bar plot is, I'm going to assign that to this ggplot. And again, we're going to give it our data. This time on the x-axis, we're just going to put the role, because that's what we want to plot. And then we're going to add, but this time we're going to add a bar geometry, right? So that's nice. So let's just see what this looks like so far. So that's our histogram, and I need to display that to the screen there. So again, now we can see kind of like the relative counts. So you see we have like a count on the y-axis here. We can see the relative count of how many instances of damage we have. So we have like almost 200 rows of our data is in the damage role, and then maybe half that in the support, and then just a little bit less in tank. So again, we get kind of an idea of how the role is distributed over our data. And here, I guess I'll just mention, it's kind of an important distinction to make between bar plots and histograms. So on a histogram, like this queue time variable, we're interested in what this actually looks like how many of our observations fall in these different bins, right? Like it's kind of, each bin is kind of like counting the amount of observations between those two values of queue times. Whereas for this, we have like different categories that the role can fall into, and each category we're kind of counting how many times the data falls in that category, right? So it's a bit different. This is kind of like a continuous variable where we're counting between intervals, like how many observations fall between these intervals. But this, we have like these different categories which we're trying to compare the different observations across each one. So I guess like your next question is probably these graphs look disgusting, right? Like what's going on? It's just gray. These axes look really gross. And we'll slowly start to make them like prettier as time goes by. I'll show you guys just a couple more things just to get started with making them look prettier, but yeah, we'll kind of, as we go, we'll add more things. But for now, let's just start with our histogram. So maybe we want a different color other than this gray. Maybe we want some lines to separate these boxes to make them a bit more distinguishable. So to do that, we're just going to go straight ahead and add some more arguments into our histogram geometry here. So we can say that we want the fill to be, and there's you can look up the different like names for the colors and like what they correspond to in Google for R, but there's like actual word names in R that correspond to like the hex colors. So this will actually fill the boxes with light blue. And then this color variable, this is gonna like just give us an outline around each box. So we can just make that black. And as you can see here, now we have something a bit prettier, like these different bins are distinguishable, and this light blue is a bit nicer on the eyes. So a similar thing we can do here. We can actually say, maybe we want to fill each box by the roll, right? So I believe, I'm not sure, I think you have to put it up here. Let me check. So fill is equal to, I don't believe myself, I believe you put it here. So fill is equal to roll. Let's see what that does. This is probably, yeah, okay, so it's not down there. Fill is equal to roll. There we go. So, and then we can make the outlines as well on here. So now we have, it filled each of the boxes by the roll. So there we go. So a couple better looking plots here. In future videos, I'll show you guys how to add the titles and maybe some more informative like axes names, because these are just the names of the variables right now. But you see, ggplot's really nice. Like we didn't even have to specify, but it gives us this nice legend on the side here, and it also it kind of auto-fills our axes, like the scale, right? So it's really nice how it automatically does that for us, and it even like chose a bin width for us that kind of shows the distribution nicely. But yeah, all things you can modify as well if you're not happy with what R did for you, but it really helps whenever you're just trying to just look at these single variables, and you don't have to type very much. These are like not a lot of typing to get these nice looking plots. So that's the start of ggplot. If we want to knit this to PDF as well, I can just show you guys what the final document would look like in our Markdown. So we have a nice title. It'll show us our code here, and then our nice plots as well. So that'll be it for this video. Hopefully I gave you guys a good start into how to actually start working with your data in R and R Markdown, and how to get some decent looking plots with ggplot. On the next time, we're going to continue with this kind of stuff, and maybe we'll find out a bit about why this distribution looks so funny, and maybe try to make sense of it a bit more based on the different attributes we have here. All right, so until next time, have a good one. This has been Chris, and see you guys later.